Hi everyone, welcome to Vedantu J English. I am Diksha Kaushal, your chemistry master teacher. And everybody, welcome and happy Dussehra to all the students out there. And today, because you have holiday, you don't have any school, so that's why I decided to take the class at 4 p.m. so that we can take a long lecture, right? I know that if I take the lecture at 8 p.m. till 12, you will be fully drained, but right now, what I expect is you are fully active, right? Yes, everybody, do let me know in the chat box if you are ready for the class. Yes, students, ready for the class? Everybody, do let me know. Let me just inform the other students as well. Wait a minute. Yes. Okay. Yes, everybody. So, in the last class, we discussed about preparation and properties of alkanes, and today we are going to discuss about preparation and properties of alkene and alkynes. Okay, and before that, I have a very good, very important information for you, a news for you, that our Eclavier test series offer has been extended, right? Because today is Dussehra, so you can get it at 999, right? Only at 999 you can get the test series where you will get part syllabus, full syllabus and topic wise test, right? All of these things you will get at just 999 here, right? Okay, so that you can see over here. Just 999 and those many things you will get. Around 150 something tests will be there in total, right? So it will be very beneficial for you. Topic wise you can start doing from now onwards, and once your syllabus is completed, like you can give part syllabus, full syllabus test to for more practice. And these questions has been made by actually looking at the previous 20 years of questions that they have asked you in the exam, right? So based on that, we have these many, we have this test series questions, okay, right? So let me see this. So the question that I gave you for homework, that is, in a given compound, the number of 2-degree carbon atoms. So what we need to do, 2-degree carbon atoms, how many 2-degree carbon atoms you have? So here if you see how many 2-degree carbon atoms, this carbon is 2 degree, which is connected to 2 carbons. Wait a minute, this will be connected to 3 carbons actually, right? This carbon is connected to 2 carbons, right? And here this will be 1 degree, right? Wait a minute, let's just write it like this, CH3, this is CH3, right? So this carbon is 3 degree, this is 1 degree, right? This is 2 degree, right? This is 3 degree, this is 1 degree, this is 1 degree, this is 1 degree. So you have 2 degree carbon is only 1 2-degree carbon you have, okay? So that means how many other carbons it is connected to, right? Now let's talk about the properties and preparation of alkenes. Now from alkenes and alkynes, like so many questions are asked, and you will see from hydrocarbons itself, right? With the mixture of other chapters, they ask you the questions, right? So please watch this lecture with full dedication. That's why I have made it like that, so that the lecture, this particular lecture should be on a holiday, so that you can give full dedication to this particular lecture. It's a very important lecture. Out of the 3 lectures of hydrocarbons, this is the most important lecture, okay? So let's talk about alkenes. So when you talk about alkenes, what are alkenes, guys? Alkenes having double bonds, right? This double bond, one single, one pi bond, that is called as alkenes. Now, one by one we'll study different things about alkenes. Now, this we have studied in isomerism, that alkenes can show chain isomer. That means, is it a terminal alkene or is this a non-terminal alkene? Based on that, They can show position isomer, whether it's terminal, the alkene is on first position or second position, right? They can show chain isomer. For example, you can have this thing also, or you can have this thing also, right? This thing also. So here the parent chain is 4, here the parent chain is 3 carbons. That means chain isomer also they show, right? This is about the structural isomerism. Then they also show you cis and trans isomerism that we have observed. They also show E and Z configuration isomerism that we have seen already in the isomerism part, right? Now, when you talk about the chain isomer, right, what is exactly chain isomer? In chain isomer, if you see this here the parent chain is 4 carbon, but here the parent chain is 1, 2, 3 carbon. So the parent chain is different, that means they are chain isomers of each other. So it definitely shows chain isomer. Now if you talk about position isomer, right, as I have mentioned, that if you have the position of double bond can change. It can be on the terminal position. Here if you write, the parent chain is having the same number of carbon. The number of carbons are not different here. But if you see this here it will be 2E and here it is 1E. So that means the position of double bond is different here, right? So here we can say it is pent 2E, this is pent 1E, right? So position is different, that's why it is called as position isomer. Next is, let's talk about the stability of alkenes. Which alkene will be more stable? This also, guys, we have done this in GOC, that is hyperconjugation we have done. So based on the hyperconjugation structure, we can tell the how many hyperconjugation structure it will form. That will tell you the stability of that alkene. For example, okay, more the number of alpha hydrogen, more will be the stability of alkene. But ma'am, if alpha hydrogens are same, but here it is not same. Here if you see, this is alpha, this is alpha, this is having 6 alpha hydrogen. Here this is alpha, this is alpha, this is alpha. How many alpha hydrogen? 3 plus 3, 6 plus 3, 9 alpha hydrogen. So definitely this is going to be more stable, right? So based on hyperconjugation, we apply the effect and we tell that which is going to be more stable, right? Okay. Now, when you talk about greater the number of attached alkyl group, highly substituted, greater is the alkene stability. Now that simply means more substituted means more alpha hydrogen, more hyperconjugating structure, more will be the stability of alkene. So directly you can say more the alpha hydrogens or more is the highly substituted alkene, that will have more stability, right? Because then we will see which is major product, which is minimum product, and that's how we are going to tell the major and minimum product here, right? Then based on the alpha hydrogen, the one which has more alpha hydrogens will have more stability, and more stability means more heat of hydrogenation will be there. Sometimes instead of asking you what is the stability of this alkene, they can ask you which will give you maximum heat of hydration. So heat of hydration, it's an exothermic thing which is given when you break this pi bond and attach hydrogen and hydrogen. That heat that is released in this process is called as heat of hydrogenation. But heat of hydrogenation, right, will be different for different alkenes, and it will always be exothermic. This is always going to be exothermic. This heat is going to release, right? So more is the stability. If an alkene is very stable, that means more heat of hydrogenation it has released. That's why that alkene is under the category of more stability. So if you see this here, this is alpha, this is having 3 alpha hydrogen, this is having no alpha hydrogen. So this is going to be more stable, and hence heat of hydrogenation will be more in case of the one which has more alpha hydrogenation. Is that clear, everybody? Yes. Saytzeff compound. Yes, when we will do from alkynes to alkene preparation, then we will talk about Saytzeff and Hoffman product. Okay. Yes, everybody, do tell me, is that clear how to connect heat of hydrogenation and alpha hydrogen? Okay, how to connect heat of hydrogenation and alpha hydrogen. This we have already seen. So next is, yes. Now, before moving towards the preparation of alkene, we need to know some important parts here regarding the mechanisms, right? So, how actually there is one kind of reaction that is called as elimination reaction, where things are eliminated, right? Now, three types are possible. First type is when you will have, let's say, from first one carbon only, H and OH both are eliminated, right? If from the same carbon, two different leaving groups are leaving, right? Elimination of atoms on the same carbon, that is called as alpha elimination. It is happening from, let's say this is A, let's say this is B. So both are leaving from the same carbon. Beta elimination is when they are adjacent to, when they are next to each other. So let's say this is A and this is B. Let's say A is eliminated, here B is eliminated. So this is alpha carbon, here this is alpha and this will be beta carbon. So it will be beta elimination when it is happening on the adjacent positions, right? Yes. Now, third is going to be if you have gamma elimination, 1, 2, 3. Now, here you have A over here. This is, let's say, B. Now, A is being eliminated from this side and B from this side. Now, if you mark this, this will be alpha, this will be beta, this will be gamma. So, the next leaving group is from the gamma position. So, that is called as gamma elimination. The three kinds of eliminations are there, right? What revision? I was just doing, dekho. Before that we did isomerism, hyperconjugation, all that. I just give you recap of what we discussed. Because this part is related to alkenes. But in detail we have already discussed hyperconjugation and isomerism, right? But this is the part that we have not discussed till now. Okay, so let's focus here. Three kind of elimination, guys, we will have: alpha, beta and gamma, right? In this lecture we will talk about mostly beta eliminations, but yes, alpha eliminations also we will talk about, right? Okay, so two kind of, just like you have two kind of substitution reaction like SN1, SN2. Similarly, this beta is further divided into two parts, that is E1 and E2. So two kind of eliminations are possible in beta also. One is E1, other is E2. So in E1, it is a two-step mechanism. Here carbocation will be formed. It is 1, that means it is 2-step. It is 2, that means it is 1 step. That's how you can remember this. Okay, it is 2, that means it is 1 step. And in 1 step, there is no carbocation, only transition state is formed. Only transition state is formed. Just like you have SN1, SN2, in the similar way you have this. Right, but obviously SN1, SN2 is in like more detail, it is asked to you, but this also you should know that what is E1, let's say this is alpha and this is the beta position, right? So what is happening here, let's say from here X is leaving, then from here H will leave, right? Firstly X is leaving and you will have the formation of a carbocation, right? This is your RDS, that is rate determining step. Right, that is your slow step, right? Here you will have the formation of a carbocation, then this H positive will leave and this bond will shift here, and hence you will have the formation of a alkene. Alkene is formed by, most of the cases you will see it is formed by elimination reaction, right? So today's lecture, most of the reactions are going to be elimination, so that's why you should have this overview, right? So this is E1, which carbocation is formed. It is unimolecular because it only depends upon this one thing, that is your the compound that you have, the reactant that you have, right? Okay. In this case, firstly X is being eliminated, then base will abstract the proton, right? But in E2 mechanism, base will abstract the proton, right? This bond will shift here, this X negative will leave, so H positive is subtracted, X negative is subtracted from here. In one step only you will have the formation of alkene. Okay, in just one step you will have the formation of alkene, right? Okay, yes everybody, tell me. Understood? So now let's just summarize this thing. E1 is unimolecular, carbocation intermediate is formed here. E2 is biomolecular, no intermediate is formed here, right? We'll discuss about these things more when we will study haloalkanes, haloarenes. Okay, in that I'll discuss more about it, like the rate of reaction, everything I'll discuss there, but not in hydrocarbons. We'll discuss that in haloalkanes, haloarenes. Okay, now let's talk about the preparation of alkenes, right? Preparation of alkenes. And you will see most of the reactions are beta elimination reactions. So let's see that. When alcohol is heated with concentrated H2SO4 at about 160 degrees Celsius, alkenes are formed after dehydration. Elimination of water is there. And that is an example of beta elimination. Hydroxyl group takes out one hydrogen from beta carbon atom. So what is happening here? What is happening here? In this case, carbon is eliminated, that is from carbon OH will be eliminated, that is alpha, and from the beta position H will be eliminated, and this will shift here, and hence you will have the formation of a alkene. But for that you need a dehydrating agent. Like P2O5 is also a very good dehydrating agent. So different dehydrating agents we will use here, right? Okay, so any dehydrating agent you can use to have alkene formation. Now guys, a very important point here is that, is this syn or is this anti, right? Wait a minute. Syn anti will not do here, na? No, that will not do here, I am so sorry. Yes, syn anti will be in chemical properties of alkene. Okay, so now how the product is formed here. So whenever they ask you to form the product, you will always form a more substituted product. That is your Saytzeff product. That says that more substituted alkene will be formed. More substituted alkene will be formed. Now, I'll give you I'll write two compounds here. You have to tell me which one will be the major, right? So guys, this is the alpha position and this can be beta, this can be, let's say, beta dash. These two are beta. So two things are possible here. Let me just write beta dash by red pen, okay? With blue I am drawing, if from beta position you have the elimination, so this will form CH3, CH double bond, CH, CH3. This is formed. If from beta dash it is eliminated, this will get CH3, CH2, CH double bond, CH2, right? These two things are formed here. Can you see that? These two things are formed here. Now tell me, if I write this as A and this as B, which one is going to be the major product? A or B, which one is going to be the major product, everybody? Do let me know. Yes, Abhishek, Shivani, Ujjwal, Rama Raju, yes, tell me which one will be the major product here. Major product. Is A the major product or B the major product? Which is going to be the major product? I am waiting. Yes, Abhinav, okay, okay. Abhinav is saying A, Rama Raju is saying A. So the major product is going to be A. Why so? Because it is more substituted product, and if you don't want to say more substitution, means there is double bond, one substitution, another substitution. Here you have only one alkyl group attached, here you have two alkyl groups attached. Another thing what you can do, this is main, this is main, this is alpha, this is alpha, this is alpha. Here you have 6 alpha hydrogens, here you have 2 alpha hydrogen, so that is why that is going to be the major, this is going to be the minor product here. So this is minor, that is major. Okay, based on that you will tell the answer, right? Okay, so now let's talk about the next preparation, that is from alkyl halides. In this case, dehydrohalogenation reaction, hydrogen and halogen will be eliminated. Dehydrohalogenation reaction. Alkyl halides react with alcoholic KOH, NaOH, eliminate 1 mole of halogen acid to form alkenes. This reaction is known as this hydrogen atom eliminated from beta carbon. This is an example of beta elimination reaction. So again, same thing will happen, but here there we use concentrated H2SO4. In case of dehydration, we are using some dehydrating agent like concentrated H2SO4, P2O5, all these things. Now, in this case, right, we are using alcoholic KOH. I am not using aqueous KOH. If you use here aqueous KOH, if you use aqueous KOH, you will replace this X with OH. That will be the answer. But here you are using alcoholic KOH, that means dehydrohalogenation. Firstly, halogen will be eliminated, hydrogen will be eliminated, bond will shift here, and hence you will have the formation of alkene in this case. So alkene is going to get formed, right? Okay. And when you talk about the reactivity of Ri is maximum, because to break the bond of the CX, now the reaction depends upon how easily you can break the CX bond, right? So we know that you have Ci, you have CCl, then CBr, then you have Ci. Down the group size is increasing. So this bond is getting longer. So that's why it is easy to break that bond. So this bond is very easy to break because the length is very high. Length is longer, it is longer. So that is the reason Ri, then Rbr, then Rcl is the reactivity in case of when we talk about alkyl halides. And if I talk about the alkyl part, then 3 degree, then 2 degree, then 1 degree is your alkyl part reactivity. That will show, that will be more reactive as compared to the 2 degree and 1 degree. Okay. Okay. Now let's talk about this one, guys. Let's talk about this one. See, bromine will be eliminated from here. This is alpha. So beta can be this, beta can be this, beta can be this. Now if I put two things are possible. Either I choose this as beta, from here it is eliminated and you have a double bond here, or I choose this as beta, then this will be the double bond. And even if I choose this as beta, then this will be the double bond, which are same only. So that means these two compounds are possible. If I say this is A, this is B, tell me which will be the major product here. Happy Dussehra, Bharat, happy Dussehra. Acha, tell me, which one you feel will be the major product, guys? More substituted you have to see. More substituted, the one which has more alkyl substituted, that is going to be the answer. That is going to be the answer. Yes, everybody, do let me know which one will be more substituted. A will be more substituted. Are you sure on that? Why you are saying A? Oh my God, all of them are saying A. How come A is the major product? How come A is the major product? More, here it is one alkyl, two alkyl, only two alkyl groups. Here it is one alkyl, second alkyl, third alkyl. To this double bond, only one hydrogen is there. So it is more highly substituted. So B is going to be the major product. If you are not able to see from the alkyl part, just see the alpha hydrogen. This is double bond. Here this is alpha, this is alpha. Here you will have 4 alpha hydrogen. Here you will have 3, 4, 5, 6, 7, 8. 8 alpha hydrogen. So this is going to be the major product. Directors, you should know how to see the alkyl part here. Right? The one which has more substituted alkyl group. Right? Okay. Then there are some reactions, that is vicinal dihalides, geminal dihalides. From there, what reagent we will use, right? So, if you have vicinal dihalide means on the adjacent position. Adjacent position you have halide, okay? So, carbon adjacent to each other and you have one halide attached to it, that is on the adjacent position. Right? Now, when you use zinc dust and the temperature is 300 degrees Celsius, what will happen? This will leave from this side, this bond will shift here and hence you will have the formation of alkene. Right? Okay, this is one of the examples of that thing, right? And hence here also, this will leave, this bond will shift here and hence you will have the formation of alkene. Right? And in in geminal dihalides, that means same carbon, on the same carbon. Now guys, see this thing, this is very important, very important. This thing is beta elimination. This thing is beta elimination. Because from the beta position, if I say this is alpha, this will be beta. Right? So, adjacent carbon, it is being eliminated. But in this case, what will happen? You will have one carbon. On that carbon, you have 2 halides. Okay? So, what will happen? This will leave, this bond will shift on the more substituted alkene. It can also shift here, but in that case, less substituted will be formed. So, that is the reason this bond has shifted here, to have more substituted alkene. Now, is this alpha or beta or gamma elimination? Let me see that. Right? Okay. Thank you, Bharat. Thank you so much. I am so happy for you. So proud of you and so happy for you. Congratulations. Right? Yes. Now, guys, tell me, in this case, what it will be? Is this beta elimination? Is this gamma elimination? Is this alpha elimination? What kind of elimination it is? Yes, everybody in the chat box, array, tell me, what kind of elimination it is? Alpha elimination. Very good, Abhishek. Alpha, from the same carbon, 2 groups are leaving. So that is alpha elimination. That is alpha elimination. And here also zinc dust is used. Here also zinc dust is used as a reagent. Okay, zinc dust will be used as a reagent. Next is partial reduction of alkynes, right? Now this is very important, right? This is very important because you will have the formation of cis-alkene and trans-alkene both. Different processes. Here for cis-alkene you need Lindlar's catalyst. And in this case you will have Birch reduction. Okay, that will be there. So here let's talk about, ma'am, what is Lindlar's catalyst. So when you will have an alkyne and you add H2 in presence of Lindlar's catalyst, that means you add H2 PD in presence of BaSO4 or quinoline or CaCO3, anything which is acting as a poison, because we don't want it to get converted to alkene. If you remember in the last class we did the catalytic hydrogenation from alkyne, directly you have alkane. But now we don't want it to convert it to alkane. We just want till alkene part. And till alkene part, what you will do to stop it, you need to add a poison. You need to decrease the rate of that reaction. So there are different type of catalysts. One is positive, one is negative. So a negative catalyst act as a poison. That means it decreases the rate of the reaction and it will make alkene. And here what kind of alkene is formed? Here cis alkene is formed in this case. Right? In this case you will have the formation of cis alkene. But if you have alkyne and you add, this is Birch reduction, when you add sodium or lithium, lithium also can be written here, in presence of liquid ammonia, you will have the formation of trans alkene, right? You will have the formation of trans alkene. This is a very important reaction. Okay, yes everybody, yes Sanjeev, tell me what is the doubt, right? So, next is Kolbe's reaction. Do you remember we did it in the last class also? What was Kolbe's electrolysis? Yes everybody, what was Kolbe's electrolysis for the preparation of alkanes? We did it for the preparation of alkanes as well, that you have RCOONA. It is converted to RR. Have we seen that? This follows a free radical mechanism. This also we have seen, free radical mechanism. Now, how it is if you have dicarboxylates, that means in one compound only you have two carboxylic acid groups. What will happen? Here homolytic cleavage will take place, here homolytic cleavage will take place. You will have the formation, this is how we used to do here, na? Here what we used to do, homolytic cleavage, then you have the formation of R, then two RR will combine and they will give you RR. Okay, this is what we did. Similarly here homolytic cleavage, this is CH2, CH2, this is one free radical, another free radical, they will join together and you will have the formation of a double bond, that is alkene. Okay, so what I will do here, CH2, CH2, this is free radical and this is free radical, and this will join together and it will give rise to alkene. And that's how by Kolbe's electrolysis alkene is formed. Okay. Thank you so much Bharat, thank you so much. Happy Dussehra, happy Dussehra. Okay, tell me, sodium potassium salt of carboxylic acid give rise to alkane. That's absolutely right. And if you use dicarboxylates, which is having in one compound you have two carboxylic acid groups, then it will give rise to alkene. Okay, it will, the same process with the same mechanism, it will give rise to alkene. Got it everybody? Right? Okay, yes. Next is pyrolysis. Now what is pyrolysis guys? What is pyrolysis? Pyrolysis is basically guys breaking of this bond. Let's see how. So what will happen here? This bond will shift here. This bond will shift here. And in this case what will happen? This is, I'll tell you how this compound of ester will give you a carboxylic acid. A carboxylic acid and alkene. Can you see this over here? Now see what is going to happen. This bond will shift here, this bond will shift here, and this bond will be eliminated. This H will shift there and this bond will shift here. Tell me. Again I am going to draw it, again I am drawing it. See, this bond will break, this bond will shift here and this bond will shift here. That means here you will have the formation of CH3, CO negative double bond O. This is double bond O and this is O negative. Okay. Then a hydrogen from here will be eliminated and this will be attached here and this will become OH. This will attached here and this will become OH. So this is carboxylic acid and this bond will shift here, which will give you formation of a terminal alkene, less substituted alkene. Can you see this? A terminal alkene, less substituted alkene is formed, right? Okay, always it will give rise to terminal alkene, right? Always it will give rise to terminal alkene, okay, always. Thank you, Daniel, thank you. Again, thank you so much. Thank you so much. Yeah. Now I am flattered. Okay, I am flattered today. You made my Dussehra very happy. Thank you so much for your loving words. It just means the world to me. It means the world to me. Right? Thank you so much for that. So, guys, see, I never ask you for likes, anything, right? But it's your duty to do it yourself. You know? If so much love, so much respect you have for me, then like this session. Why do I have to ask it again and again, right? You will rarely see me asking for that, but if I don't ask, that doesn't mean it doesn't make me happy. It makes me really happy, right? So like it, comment down, share this video with your friends as well, right? Yes. Tell me guys if there is any problem. Honey, till now we are not doing any product, any reaction where rearrangement is required. Okay, till now we have not done any. If it is required, I will tell you that it is. You will do rearrangement here. Okay, I will specially mention that. Right? Happy Dussehra, happy Dussehra. Acha, tell me, is that clear how this works? Is that clear how pyrolysis means breaking of the bond, right? And here, what do you mean by Hofmann product? Hofmann product is opposite of Saytzeff. In Saytzeff, you have more substituted alkene. In this case, you have less substituted alkene, right? Okay. And you know what will happen here? You know what will happen here? This particular, wait a minute. Just give me a second. Why we have written carbon ion here, that also I will tell you why we have written it here. Because you know what will happen here? This bond will shift here and it will lead you to the formation of a carbon ion. This carbon ion will be formed. That's why we have written carbon ion is the intermediate here. Okay? Yes, everybody, do let me know if that is clear. Do let me know if that is clear. Actually, if you want to know the mechanism, actually what is happening here, how carbon ion is formed, it is not that important, but if you want to know that how it is formed, so see this. This is hydrogen. So firstly, hydrogen will leave and you will have the formation of CH3, CH negative, CH2O, C double bond O, CH3, right? This will leave and this bond will shift here and you will have a negative, that is carbon ion. Now when this carbon ion will shift here, then this bond will shift here and then this bond will shift here. And that's how you will have the formation of CH3, CH double bond CH2, and you will have CH3, COOH. Okay, that thing is formed here. Understood, everybody? Definitely, Sudha, definitely you can watch that. Wait a minute, let me also tell that. Okay. Thank you. I'm literally too much flattered. Okay, tell me. Got it? Yes. Acha, that is done now. Now understood what is happening here, what we are doing here, right? Now, this we have done, and now let's see the next one, that is Wittig reaction. Now in Wittig reaction, just directly know the product here. Just directly know what is the reactant and what product will be formed, right? So in Wittig reaction, what you have yelide. What is yelide? Phosphorus yelide you have. Yelide is this compound where phosphorus is connected to three phenyl groups, one alkyl and another alkyl, two alkyls and three phenyls. And here you have ketone. So what will happen? Here you will have the formation of double bond O, right? And here you will have the formation of, wait a minute, achha, double bond O is already there, na? Yes, 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 yes. See, you have this compound here, this is R double dash, this is R dash, this is R. So this carbon here will be connected here, you will have R and R dash. So that thing is formed. That means interchange will happen here. This particular compound here, this particular compound here will shift here, that is C, R and R dash. And to this part you will have the double bond O, right? So that's how from yelide you have the preparation of alkene, right? That's how if you want to make this carbon, this R dash and this R, this is all together connected to this particular bond, it will shift here, this will give rise to C, this is R dash, and this will form double bond O here, and that is going to be your final product. Tell me, is that clear everybody? How from yelide you have the formation of alkene? How from yelide you have the formation of alkene? Correct everyone? Now let's talk about physical properties of alkenes, right? Let's talk about physical properties of alkenes everybody. Let's talk about physical properties of alkenes, right? So firstly, the data here, C1 to C3 is gaseous, C4 to C20 is liquid, and C20 onwards is solid in nature, right? Yes. Dipole moment, if you talk about, dipole moment of cis is always more as compared to trans, because in case of cis what happens, right? Let's say this is R and this is R dash, right? This is trans, basically this is trans, let me just draw cis here, this is cis, okay? And this one is trans. So what will happen in case of trans? This will and this will cancel each other, and here they will not cancel each other, here they will get added up. So that is the reason always cis will have more dipole moment as compared to trans. That is why this, from here questions also they have asked in JEE 2025 only, right? Okay, yes. So melting point. Now if you talk about the melting point, directly proportional to packing efficiency, packing efficiency of trans is more as compared to cis. If you see, cis will look like this and trans will look like this. So the packing efficiency, that means it's like chair, right? You have one chair, you can put another chair, on and on it, right? So that is your packing efficiency. But if you have this kind of situation, then other has to be smaller. This has to be smaller, this has to be smaller, this has to be smaller. That means the packing efficiency of cis is not good, trans is good, right? So trans has better packing efficiency, so the melting point of trans is going to be more as compared to cis. And based on this also they have asked you the question, this is also very important. this is also very important. Statement based questions, they ask from cis and trans and the properties which is more stable. Now trans is more stable because no steric repulsions are there. Cis is less stable because of steric repulsions, right? Now let's talk about the boiling point. Directly proportional to the molecular weight, inversely proportional to the branching, right? So now if you see this here, right, this is trans, this is cis and this is trans, right? In this case, cis will have more boiling point, right? Cis will have more boiling point as compared to trans, right? Okay, that is different and that is important because the melting point order is exactly the opposite. But it has been observed that cis has more boiling point but it has less melting point, right? Then color and odor. Color and colorless and have no characteristics odor except ethene, which have pleasant smell, right? Only ethene will have a pleasant smell, others are odorless, right? Okay, chalo. Acha, do you remember this? I told you this yesterday also. Before going into the chemical properties of alkenes, we have to study this. Do you remember, bacha? Do you remember this thing? Tell me. I think it has been, I think it is provided already. I'll check that, right? And your resonance PPT, your acid basic strength PPT, I have sent to the team because today the team is on leave and like yesterday only we took the lecture till 11 p.m. So after that I have sent, but right, it's like your ma'am is working, not everyone is working, guys, right? So everyone is there. So it's Dussehra holiday, so that's why tomorrow it will be uploaded, right? Okay, yes. Understood? Yes. Okay. Acha, do you remember this, bacha? Do you remember this? Tell me. I'll just revise this. If you have cis alkene or trans alkene, or you have syn addition or anti addition, what kind of addition you are doing? Now, if it is cis and it is syn addition, or if it is trans and it is anti addition, it will be erythro product, right? If it is cis and it is anti addition, if it is trans and it is syn addition, then it will be thereo product. If the signs are same, it will be erythro. If the signs are opposite, it will be thereo product. What is erythro product? Erythro product is, for example, you have added chlorine. So chlorine will be on the same side. Thereo product is chlorine will be on the opposite side. That is erythro and thereo. Okay, yes, very good. Now you will actually understand where we are going to apply this. Okay, so let's understand this one by one. So first thing is addition of H2. When these are the reactions of alkene which are very, very, very important, guys. So please have full focus here on the board, right? Syn addition, anti addition, where thereo erythro product will be formed, that is very important, right? So when you talk about addition of H2, that is syn addition and that is exothermic in reaction. That is an exothermic reaction, energy is released here and it is syn addition, right? And whenever you added, pi bond will break and H2 will be added. Pi bond will break and H2 will be added. Pi bond will break and H2 will be added. This is what we do. Now here you have alkyne. From alkyne, propane is formed if there is no poison. And here if you add poison, then you will have the formation of cis alkene, right? But here we are not adding poison, so directly alkane is formed. Acha. That I'll do in the next half. We'll do questions based on this. Just give me a second. I just want to give you an overview here. Addition of X2. If you add X2 here, that is actually an anti-addition, right? That is anti-addition. We'll talk about this. That is anti-addition. Now I'll tell you why it is anti-addition, because now here after breaking the pi bond, this kind of product is formed. this kind of intermediate is formed, that is cyclic intermediate. That is why another halogen will attack from the opposite side. That is why this is anti-addition, right? So addition of halogen here is the anti-addition, right? Anti-addition will be, we will do here, right? Okay, yes everybody. Now, yes, wait a minute, let me do 1-2 reactions here. Yes, this is what I was looking for. Wait a minute, yes, okay. Let's see this. Why it is so? Why it is anti-addition? Why anti-addition? Ma'am, why anti-addition? It is anti-addition because when you break this pi bond, X will form a cyclic halonium ion. Cyclic halonium ion is formed. That is why the next halogen is going to have the opposite attack, the anti-attack, right? That is why we are saying anti-attack is happening here, right? Okay, anti-attack is happening here. In case of hydrogenation, syn attack. In case of halogenation, anti-attack is there, right? So if this kind of question is asked to you, tell me guys, is this cis or trans? Is this cis or trans, everybody? Is this cis or is this trans? Yes, everybody in the chat box. Is this cis or is this trans? Yes, everybody in the chat box. What do you call this? Cis or trans? Cis or trans? Not that of a tough question I have asked. Cis, right? This is on same side, so this will be called as cis. Now tell me, if you have cis here, then what will be here? D2 and Ni, that means this is hydrogenation. Instead of hydrogen, you are adding the isotope of hydrogen, that is deuterium. So is this syn or anti-attack? This is syn attack, this is syn addition. And addition of Br2 in CCl4 in presence of CCl4, right? That is anti-attack, that is anti-addition, that is anti-addition. So you have syn addition, you have anti-addition here. Now this is positive, syn addition means positive, anti-addition means negative, and cis means positive. When you have positive, positive, you will have the formation of erythio compound. Erythio compound, that means this carbon has one hydrogen, wait a minute, another hydrogen here, and deuterium is added on the same side because it is a plus condition. It is a erythio compound that is formed. And in this case, you will have the formation of therio compound. How? Because this is negative, positive, opposite number, that means therio compound is formed. This will become CH3, CH3, this CH3, CH3, 1, 2, 3, 4, 1, 2, 3, 4. To this carbon, you have the attachment of hydrogen and one Br is added. One Br is added on the opposite position here because this is a therio product. The added is on the same side. The added addition at the atom that you have added is on the opposite side. The group that you have added is on the opposite side, that is called therio, and this is called erythio. Tell me, is that clear? How syn addition and anti-addition works in case of alkene, right? Tell me. Is that clear to everybody? Is that clear to everybody? Is that clear to everybody or not? If here I have, let's say I have opposite thing, let's say I have here trans, okay? Let's say I have here trans. This is CH3, this is H. So this will become trans. This will become trans. Trans means a negative, right? Okay. Now in this case, what is going to happen? In this case, what is going to happen? What addition will take place? What addition will take place where? Where you will have thereo, where you will have erythro. This is positive, this is negative, positive. Signs are opposite. That means deuterium will be added on the opposite side. Because signs are opposite, that means thereo compound is formed and deuterium will be added on the opposite positions here, and hence this will be the product. In this case, what you will have, Br, this is negative, negative. That means Br is added on the same side. Br is added on the same side, and you will have the formation of erythro compound. You will have the formation of erythro compound. Tell me, is that clear? Okay. Yes. No issues. Yeah, today I have a target of completing alkenes and alkynes, right? Because I want to complete this by tomorrow, right? That is only possible. I'm not saying that alkyne fully we will do. Chalo, if till 7 also we do, right? 2 more hours if you're able to study, then I'll be able to finish most of the chapter. And tomorrow then we don't have to, because no, tomorrow you already will have school or whatsoever, right? Then it will be difficult for you. Today you have holiday, so you can concentrate more, right? Okay, so that's why this thing. Tell me. Don't worry, I'll not continuously take the class, I'll give you the break, right? It's just 1 hour now. After 30 minutes, I'll give you the break, okay? I'll give you the required break after 30 minutes. I'll give you 5 to 10 minutes break, then you relax, freshen up yourself. I think after 30 minutes or maybe 40 minutes, our alkene part will be over, little bit alkene part will be left. Once it is done, right, most of the things, because alkyne is quite short only, right, then 1 hour for alkyne, okay? Yes. Now, this we have studied. Now, addition of X2. Reactivity will be F2 is highly reactive, then Cl2, then Br2, then I2. This is the reactivity of halogens that you add here, right? Then bromine water test. Now, what is bromine water test? Reaction with bromine is basis for test of alkenes, right? So, this is a test of unsaturation. Can you tell me what is the color of bromine water? Bromine water has brownish, reddish brown vapors, right? It exists as reddish brown vapors, right? Reddish orange color of bromine solution is discharged. For example, you have alkene, you add bromine vapors, then this particular part will be discharged because Br and Br will be attached here, right? This compound here, this is brownish red color, and it will be converted to a colorless compound, right? That is your vicinal dihalides, it will be converted to, which is colorless, and that's why we say that the reddish orange color of bromine solution is discharged. The reddish brown color of the bromine solution is discharged, it is eliminated, and when you see a visible change in any reaction, you test, you make it, you tell that, okay, this is a distinguished test, because we need visible change. Either we should see the color, or we should smell, we should see some change in the odor, right? These things should happen, or there should be some precipitate formation, right? Something different that is visible, right? That should happen. These are considered as distinguished tests. So here, if it gives positive test for bromine water, that means there is unsaturation present here. There is pi bond present here, right? That means there is pi bond present here, right? Okay. Next, everybody. OMG, but bromine is quite dangerous. Bromine is quite dangerous to play with. So, take care next time, right? So, this has happened in our lab in masters. Some students was like, you know, playing in the lab with the chemicals, right? Boys in our class were next level. They used to like literally play games with the chemicals, right? So there was altogether fire in the class, not that much. Our lab attendant handled it very well, but that was a scary scene. So don't play with the chemicals. Like, chemicals are sometimes very dangerous, right? Always they are very dangerous, right? It just depends upon which reaction. You never know which reaction. If one reaction, exothermic reaction takes place, then, right? So be aware of the chemicals in the lab, right? Now you have addition of HX, right? This is H positive, this is X negative, and here you will learn about Markovnikov rule and anti-Markovnikov. Markovnikov and anti-Markovnikov rule, that we'll discuss about, right? So here pi bond will break, H positive will be attached, X negative will be attached, but the question is, ma'am, how it will be attached? So when it is on the symmetrical alkene, then there is no problem, right? In symmetrical alkene, hydrogen and halogen, any side can be attached, product remain the same. This reaction is electrophilic addition reaction, right? But in case of unsymmetrical alkenes, in case of unsymmetrical alkenes, what is happening? We have to apply Markovnikov rule. That means negative part to less number of hydrogen. Negative part will go to less number of hydrogen. For example, you have this compound. Now either Br negative H positive, either Br can attach here or Br can attach here. Where you have less number of hydrogen, this case. So it will be the major product. That is why where Br is attached to the less number, that is going to be the major product. That is going to be the major product. And where Br is attached to the more number of hydrogens, that is going to be the minor product here. So that is the reason this is major, this is minor product. Okay, that is called as Markovnikov rule. Okay, negative part is attached to the less number of hydrogen. Okay, that is Markovnikov addition, right? Now, why it is so? What is the mechanism? Let's talk about this. So, what exactly happens here? You add H positive, right? And when you add H positive, pi electrons, they are shifted here, right? If I am saying two things can happen, either pi electrons can shift here or pi electrons can shift here. Okay. When pi electrons shift here, this will be positive. When pi electrons shift here, this will be positive. So, two types of carbocations can be formed. Now, tell me, according to GOC, which is the more stable carbocation? This has, now do you remember Barhi? According to hyperconjugation, this is alpha and you have 2 alpha hydrogens here. Here you have 6 alpha hydrogens, so definitely this is going to be more stable. Usually students answer it by inductive, but I will answer it by hyperconjugation because hyperconjugation is more dominating, right? So this is more stable and that's why X negative is attached here and that's why this is the major product, right? So directly we tell Markovnikov as that there will be negative part will be attached to less number of hydrogen, okay? Right. So formation of carbocation is the rate determining step here. Rearrangement of carbocation to more stable carbocation can occur to form more stable product. Achha, have we discussed about rearrangement? We have not discussed about rearrangement, right? Have we? I don't think so. We have discussed. So I'll just explain you about rearrangement here, right? Okay, so let me just explain, wait a minute, what I'll do, let me just explain you about, now I really doubt that if we'll be able to do that much today, right, because rearrangement is itself a topic, right, I totally forgot that I have not taught you that, totally forgot. So guys, what is rearrangement of carbocation, right? rearrangement of carbocation. Okay, I'll just tell you the application part of it. Rearrangement of carbocation. Achha, today I'll not teach you ring expansion, contraction, that I'll take up in some other chapter, okay? Because you know, this is the throughout we can learn, right? I'll specially teach you, because today though I have not planned it according to that, right? If I teach you ring expansion, contraction, half an hour, so it will take for that only. Then we will not be able to complete all the reactions today, right? So what I'll do, I'll specially write it on the thumbnail also, that rearrangement of carbocation I'm going to take up, so that other students who watch it on the recorded version, they click because of preparation properties of alkene, alkyne, so they want to see that only. So I'll just give you that how it is used in the questions, okay? Now see, if you have a carbocation, let's say this one, let's say this is the carbocation. Now this carbocation is a primary carbocation. So what will happen, this hydrogen will shift here, right? CH3, this will be CH, one hydrogen will shift here, and hydrogen with the negative will shift here. Oof. So if you see this here, hydrogen with the negative will shift here, right? That means hydride will shift here. This hydride will shift to this place, and hence you will have the formation of CH positive. This is CH3. Okay? Not CH3. Wait a minute. If I am saying this should be CH2, 3 and 4. Yes. This will be CH3. Now if you see, this one is 2 degree. So to convert it into a more stable carbocation, the shifting will happen, right? Now let's talk about another shifting, that is, wait a minute, another shifting, that is, wait a minute. Ma'am, can only hydride be shifted? Can there be any other things that can be shifted? Okay, let's talk about that, right? So guys, if you have, let's say, wait a minute, right? So guys, let's say you have 1, 2, 3, 1, okay, this is positive here. This is the group that you have, right? Now in this case, this is the compound that you have, carbocation is here. This is a 2 degree carbocation. Now this is CH3, this is CH3, this is CH3, this CH3 can also shift here, and it can give you, it will shift here, and here you will have, because this particular will remain as it is, this methyl group will shift here, and the cation will shift here. Now if you see, this will be a 3 degree carbocation, but here you will have methyl shift, okay, in this case, and here you had hydride shift, and this was hydride shift, this was hydride shift, right? Now next is, ma'am, what if you have a situation, ma'am, where we have let's say you have 1, 2, 3, and this is pH, right? This is also pH, right? And this is also pH. Same thing, this is positive, right? Now in this case, ma'am, can phenyl also shift? Yes. Phenyl can also shift here, and hence you will have the formation of 1, 2, 3. Here you will have 1 phenyl attached. Here already 2 phenyl will be there, right? And here you will have positive. Now this is a 3 degree carbocation with the resonance with the phenyl group. There will be resonance, right? Okay, and here you don't have as such resonance. So this is only 2 degree, right? This is 2 degree, this is 3 degree with resonance. With resonance, that means a more stable. And you can only shift the hydrogen, methyl or phenyls in the adjacent position, right? On only the adjacent. If on the adjacent position it is becoming stable, then one more position you can do, right? For example, let's say you have this one. Let's say, guys, you have this thing. Let's say you have this compound here, that is oxygen. This is positive. Now tell me, is there any shifting required? Is there any shifting required? This is 2 degree, right? But ma'am, if we shift it here, this will become also 2 degree. But in this case, if you see, back bonding will also be there. Plus back bonding, plus resonance is also there. So that is the reason here what is required? Here this one will be required, 2 degree plus back bonding, right? Okay, everybody. So here it will get banged. So all you need to understand is you need to have a more stable carbocation. If you are getting after rearrangement more stable carbocation, rearrangement will be done. But this will be only in those cases where carbocation is the intermediate. If carbocation is not the intermediate, you will not do that. Now let me take one more example. That what if you have this kind of situation? Here you have one methyl, this is one phenyl, and this is positive. Okay, so 2 phenyls. Now tell me, you have a choice. If you want to shift something, you can shift phenyl also, you can shift methyl also. So in these cases, remember the priority order always, that is happy me, right? So it is hydrogen, then phenyl, then you will have methyl. That is the migratory aptitude here. That is the migratory aptitude. So phenyl will be shifted in this case, and hence you will have the formation of 1, 2, this is pH, and this is methyl, and this is pH, and here you will have positive. So this carbocation will be formed. Tell me. Yes, Sandhya, you can watch this, guys, you can watch this, right? Thank you. Chalo. Now tell me, is that clear? Rearrangement? Beta, I have not explained you rearrangement in detail till now. I have just given you what is required in this lecture. Okay? In detail, it is more towards rearrangement. We'll do it in some other lecture as well. Right? Okay? Yes. Tell me, is that clear, everybody? Rearrangement, how it is done? Okay? Now you have this compound. Now in this case, you just directly apply the application here. That is, this is positive, this is negative. Negative part to less number of hydrogen. So this will become CH3, CH, CH2, this is H, and this is Cl. Right? So that will be the answer. That means this will become CH3. So negative part to less number of hydrogens you have attached. Okay? Then you have next thing, that is this one. Negative, this is positive. Right? Here you will have carbon and 1 hydrogen. Here you will have carbon and 1 hydrogen. Wait a minute. Here you have to see. Okay? Here directly, can you see? You are not able to find this directly because both have same number of hydrogens. Now anybody? For these kind of questions, concept is needed. Right? What is the concept? What is the basic idea of Markovnikov? Carbocation stabilization, right? You need to have a stable carbocation. So that means 2 things can happen. This is the bond. So now this pi bond here, this pi bond here will break. Either it will give a positive carbocation here or it will give a positive carbocation here. Right? If it gives positive carbocation here or if it gives positive carbocation here, you just have to tell me which is more stable. Which is more stable. If you get this positive carbocation, this is also 2 degree. This is also 2 degree. Right? But one thing I can assure you that this carbocation is more stable here. This is alpha 2 hydrogens. This is alpha. You have only 1 hydrogen, right? But you know what is happening here? If you again rearrange this, rearrangement can also take place. Now, this is, if you again rearrange this, hydrogen, if it shifts here, you will have this kind of rearranged product, isn't it? You can have, this is 2 degree and this is 3 degree. So rearrangement is possible in this case. So we will do that, right? Now you attach Br negative. Now it will be Br negative here and this thing will be formed. So see how beautifully we have never even thought that Br can also attach here, but it is attaching here, right? Because rearrangement is possible in case of Markovnikov addition, right? Okay, yes, tell me. Understood? Yes, everybody? Clear? Chal. Now, let's talk about the next part, that is reactivity order towards addition. So, HI, HBr, HCl, HF, that is a reactivity, because all we need to do is more, if we are able to break this bond easily. This bond breaking should be easy. If this bond breaking is easy only if HX length is more. So in case of HI, it is longer, that's why it is easy to break HX bond, that's why it is highly reactive. Okay. Now if you use peroxide here, peroxide means that you are using a peroxide with this kind of bond, like this is ROOR. Mechanism is not important for you here. Which thing is important? That anti-Markovnikov product is formed where Br is attached to less number of hydrogens. So here Br is attached to more number of hydrogens. So this will give you anti-Markovnikov product. This will give you anti-Markovnikov product. If you attach it here, this will give you Markovnikov product. Two things are possible, anti-Markovnikov or Markovnikov, two things are possible. So here, if to less number you have attached, then Markovnikov rule. If to more number you have attached, it will give you anti-Markovnikov rule. Okay, right? So basically why this happens? Because it follows a free radical mechanism. This mechanism is not important for you. You can just go through it that okay, firstly peroxide will break and it will give you a formation of OR free radical, then it will break, then it will further give you this homolytic cleavage and you will have the formation of ROH here, this RO free radical and H free radical, and here you will have elimination of one Br free radical, This Br free radical will attack on the pipe bonds, right? And hence it will give you a further free radical here. Two free radicals are possible, this or this. Now this is a major product here, right? Because free radical stabilization is more in this case, right? So the major one, after that what will happen? Again HBr, this will again free radical. This H free radical will again attack here and you will have the formation of the product. So all you have to remember is that this is a free radical mechanism. Because of the free radical mechanism, here anti-Markovnikov product is formed. Okay, anti-Markovnikov is present in the presence of oxide, is not applicable for, very important, it's not applicable for HCl or HI. HCl or HI will always give you Markovnikov addition product no matter what. Always they will give you Markovnikov addition product no matter what. HBr is going to give you different product for Markovnikov and anti-Markovnikov. Tell me, is that clear, guys? Is that clear? Anti-Markovnik HBr will give you different. So for example, right, like why so, ma'am? Why HCl does not give us anti-Markovnikov? Because what will happen if you have a free radical, and here also you want to make a free radical, have production of H and this here, what will happen? This H free radical will attach here and it will give you the formation of CH2Cl CH3. But this particular step is so endothermic, a very high amount of energy is required here, that this step will not take place only, because high amount of energy is provided to make this step reality. So that is why, because of this, for HCl, anti-Markovnikov is not applicable. For HI, why it is not applicable? Because this is a reversible. Again, this is a very high amount of energy. Even this is how much? 12. This is 46 kilojoule. That will make it reversible process, right? So that is again the reason, because high amount of energy is required. It is also not applicable for HI, right? So in case of HBr, both are applicable, right? Both are exothermic. That's why both are exothermic. That means energy is released in that step in case of HBr. So that's why HBr will give you anti-Markovnikov also and Markovnikov also, depending upon if you have used peroxide or not. But HCl, HI will give you the same product with peroxide or without peroxide. Let's see this particular reaction here. Yes, everybody. Ready for this one? Ready for this one? Yes, everybody. Tell me about it. If you're ready for this one, okay? Let's see this here. So, what you have here, you have an alkene. If you add HCl, then what will happen? Markovnikov addition will take place, and here to the less number you will have the addition of negative part. Even if you have HCl in case HCl and peroxide, still it will give Markovnikov addition only. Here also it's Markovnikov, here also it's Markovnikov. Okay, so here it will be CH3, CH, Cl, CH3, right? In case of HBr, right, if you have only HBr, negative part is attached to less number of carbons. But if you have peroxide here, here you are using Markovnikov addition only. Markovnikov rule is only applied. But in this case, you have anti-Markovnikov addition. So here what you will have CH3, CH, CH2Br, and here you will have anti-Markovnikov addition product in case of HBr, right? Okay, break will come. Kit Kat break panta hai. It will come, beta. Don't worry. Firstly, let's study something, right? Okay, break will come. Don't worry. You get exhausted very easily, huh? Why so? What is the reason? Why so? Let's do at least complete the reactions of alkenes, right? Because I don't want to, after the break, I don't want to start with again something like, you know, in between only, right? So let's at least complete the reactions of alkenes and then take a break of 10 minutes, right? Addition of hypohalous acid. Hypohalous acid is HOX. That is, this is, wait a minute, this will be positive, this will be negative, this will be positive here, right? So here what will happen, let's talk about that. In case of hypohalous acid, that is HOX. In case of hypohalous acid, that is HOX, what is going to happen? Firstly, guys, in the slow process, right, hypohalous acid means simply water and X2. This forms hypohalous acid. So in reality, what is happening? Firstly, Cl will get attached. It will form a cyclic halonium ion, right? Then with the anti-attack, you will have the attack of oxygen here on the anti. This will be the anti-attack. Wait a minute. Anti-attack. Anti-attack will be there, right? So on the other position, you will have OH2 attached from oxygen, because oxygen has 3 bonds, so it will have a positive charge here. Now oxygen cannot handle a positive charge, so this will be eliminated. This bond will shift here, and hence you will have the formation of halogen on one carbon and OH on the other carbon. This is how it will take place, right? Just remember that here anti-addition is there because you will have the formation of a cyclic halonium ion, right? This is same as how we added addition of X2. In that we just added X2, there was no water. If there is water also, then instead of adding next chlorine, we'll add H2O here. And that's why OH will be placed there, right? Okay, and that will be your answer here. Now let's see, this is the question. So this is negative part is what? This is the negative part. So negative part will be attached to the less number of hydrogen. So that's how this is the product that you will have here. Okay, this is the product that you will have here, right? Now guys, let's talk about addition of H2SO4, right? Addition of H2SO4. So with concentrated H2SO4, what will happen? You have concentrated H2SO4. This also gives H positive. This also gives OSO3H negative, right? So H positive will be attached and OSO3H will be attached, and you will have alkyl hydrogen sulfate, right? Always remember, negative part will be attached to less number of hydrogen. So in this case, OSO3H, this negative part and this is the positive part, this is attached to less number of hydrogens. Okay, simple. Markovnikov rule only we are applying everywhere, right? Addition of NOCl, again you will have the same thing. This is NO positive, Cl negative. Negative part is attached to less number of hydrogens. Again it is Markovnikov rule. Now this is called as Tidden's reaction, not Tilden, it's Tidden's reaction. Okay, Tidden's reaction, where you have the addition of NOCl. These are some small reactions that are, this is not there in your NCERT. If you are a NEET aspirant, you can avoid this, but I would advise you to do this, right? JEE aspirants, definitely you have to do this. Okay? Yes, everybody, tell me. Okay. Yes. Shreyas, have you watched the lecture like anti-sin? Because sin addition means from the same side. Anti-addition means one substituent is attacking from this side, other is attacking from this side. So when you have a cyclic intermediate, then one other intermediate will attack from the opposite side. That is called anti-addition. Okay. Acid catalyzed hydration. So in this case, what will, now there is a part called hydration, and from here also lot of questions are asked. 3 category of hydrations we have: acid catalyzed, hydroboration-oxidation and oxymercuration-demercuration. All of them are very important directly. The product part is very important. Okay, right? Okay, yes. Abhishek has his own mnemonics to remember things, right? Yes, X is always halogen. X throughout organic, wherever I am writing X, it is halogen only. Okay? Yes. Tell me. Let me see how many likes you have given to the session. Let us see that. Array. No break. Finish syllabus asap. No, I will give you break. Don't worry. Right? Acha. Now 3 kind of hydration, guys, you have. First is acid catalyzed, then there is Markovnikov, then there is hydroboration-oxidation, then oxymercuration-demercuration. 3 hydrations. So in all the cases you are going to form alcohols. But here Markovnikov addition is done and rearrangement of carbocation will take place. Markovnikov addition with the rearrangement of the carbocation will take place here. If you can convert it into a more stable carbocation, you will do that. That is your acid catalyzed hydration. Okay. Hydroboration oxidation, everybody. Hydroboration oxidation. Just firstly mechanism I will tell you later. Firstly let's see what is happening. Here anti-Markovnikov addition, no rearrangement, no carbocation only, no rearrangement, right? So anti-Markovnikov addition. In case of oxymercuration-demercuration, you will have, very important, Markovnikov addition without rearrangement. Here you will add Markovnikov addition, but this will be without any rearrangement. Let's see how it is done. At this point, I am not even talking about reagents, nothing. I just want to tell you, with the name you should know that what different products can be formed, okay? So in case of acid catalyzed hydration, first you will make a carbocation, more stabilized carbocation, and then you will convert it into alcohol. There is no rearrangement possible. You will convert it into alcohol, right? Here this is oxymercuration-demercuration. I will tell you how reagents you will see. This is mercury in water, oxymercuration-demercuration. In this case, you don't have to make the carbocation, directly Markovnikov rule. Here Markovnikov rule is applied, but here rearrangement will not take place. So directly to less number of hydrogens you will attach OH and this will become CH3. If you have hydroboration-oxidation, directly you will apply anti-Markovnikov rule, that is CH3, CH2, CH2, and this will be attached here, that is OH. That means negative part to more number of hydrogens, that is your anti-Markovnikov addition, right? Okay. Shivani, I think it is done already. Yes, we do that. If it is not happening, then I'll ask the team why it is not happening. Okay. Yes. Done? Tell me. Now let's see, ma'am, what exactly are these different things. In acid catalyzed hydration, you will have water and any acid which is going to give you H positive. Here carbocation will be formed and rearrangement will take place. Then you will have the attachment of OH. Right? In hydroboration oxidation, there is no carbocation that is formed here. In this case, in fact, anti-Markovnikov, that means to more number of hydrogen negative part will be attached. The reason is its mechanism. So what exactly happens here? You will have 3 alkenes here and you have diborane here, right? So one hydrogen, so you have BH3, right? One hydrogen here is replaced by the alkyl part. Break the double bond and this will be CH2, CH2R. This is the alkyl part, right? Then you will have another hydrogen that will be converted to alkyl. Then the third hydrogen is also converted to alkyl. So in the end you will have B, this alkyl and thrice, right? Okay. After that, with the oxidation, I think next step is not written here. Next is you will add oxidation step. Next step is the oxidation step where you add H2O2 in THF, that is oxidation step. There what will happen? This alkyl part will come out and here you will have the addition of, this is also CH2, OH in the terminal position that is attached to the boron, right? And here you will have the addition of hydrogen here, right? And that is the reason anti-Markovnikov terminal product is formed, or you can say directly anti-Markovnikov product is formed, to where more number of hydrogens are connected, right? Okay. In oxymercuration, demercuration, guys, you have this alkene, right? This directly forms Markovnikov addition product without any rearrangement. The reagents are NaBH4NaOH. This is, both are the reagent. Both are the reagent. You will have acetate, that is mercuric acetate here, right? Mercuric acid is already mentioned here. Mercuric acetate, this means CH3COO twice Hg and water. And second step is oxymercuration. This is the oxymercuration step, right? This is demercuration step where you are adding a reducing agent, right? Directly remember that it is going to follow Markovnikov rule without any rearrangement. Okay guys, tell me, is that clear? Is that clear everybody? Acha. Now see this. Now see this everybody. Okay, yes. Now let's see this. Okay, I'll just give you one compound here. Let's see this one. Let's see. Let's say you have, this is pH. Let's say you have this thing, okay? Okay, this thing we have, this compound we have. Let's see what will be the answer in all these three cases. Okay, let's see what will be the answer in all these three cases. Let's see that. Okay, right everybody, let's see what will be the answer in all these three cases. First is acid catalyzed hydration. So you'll have to make a carbocation here, right? That is going to be pH 1, 2, this bond will break, and either you can have positive here or positive here, right? If I have a positive here, that will give me more benefit because I can now rearrange it and convert it into pH positive, this thing. Now this will show you resonance. This is only 2 degree, this will show you further resonance. So now I will attach the alcohol group here. That means in acid catalyzed hydration, I have firstly converted it into a carbocation part. Then after that, I have done the rearrangement and then I got the answer. In oxymercuration, demercuration, I'll not even think about that. I'll see this is how many hydrogen? 1. Here you have no hydrogen, so it will be attached to the less hydrogen part. So this will be pH. Directly Markovnikov rule is applied. This will be, and here you will have the attachment of OH, where less number of hydrogens are connected. Okay, that will be your answer. In case of in case of hydroboration-oxidation, what will happen everybody? Let's see that. Hydroboration-oxidation, anti-Markovnikov rule is applied. Okay, anti-Markovnikov. I don't know why the cursor is moving here. I am not asking the cursor to move here, right? I hope so. Now it will not move. Yes. So anti-Markovnikov, that means to more number of hydrogen. That means this is pH, this is this OH, 1, 2, and this is going to be your final product. Tell me, is that clear everybody? Is that clear? Right? Is that clear everybody? Tell me. Okay? All clear? Sab saaf or sab saaf? Right? It should be sab saaf. Right? Okay? So let's do some more reaction. Let me see how many more reactions. Next is your oxidation reactions. That will do after the break. Okay? That will do after the break. Then chemical properties you will have. like so much amount we are left with right now, don't worry. So we'll do that after the break. Now I'll give you break for 10 minutes, right? Right, okay? Okay, now I'll give you break for 10 minutes now because it's already almost 2 hours. So you can have your break, right? Okay. Yes, guys, up for the break. Now I'll see you all at, this is 5:54. So I'll see you all at 6:10 or 6:05. Okay. So it's a break time. In the break time, what we do, I'll not use this slide because after this the reactions are your, wait a minute. Reactions that we have is oxidation, then alkene. Alkene has so many more reactions that we are left with. Ozonolysis we have to do from where the questions are like asked so many times, right? Alkene is a smaller part. So even if we are able to do half of the alkene today, that will also work because aromatic hydrocarbon is a very, like hardly 1 hour class will be there for aromatic hydrocarbons. So what I want to do today is that today we complete alkenes fully and we complete the preparation step of alkynes, right? Physical properties and chemical properties of alkyne we'll do in the next class. That will work, right? That is okay. But at least we start alkynes today. We complete the preparation of alkynes today. And I think 1.5 hour is enough for that after this class, right? So I think we'll be able to do also physical properties. So we'll only left with chemical properties of alkynes and aromatic hydrocarbons, which is good to go, right? Okay? Yes. So now I'll see you all at 6:05, okay? At 6:05, I am giving you 10 minutes break. 10 minutes break. You know, I'll not put this slide. This looks little weird, right? Wait a minute. Ma'am, you will waste your time like this only. This is what I feel. I don't want this. Why it is not working only? I don't know. I don't know. Conduct PYQ session, ma'am, after completing this chapter. I'll do that. PYQs altogether for just hydrocarbons. I just want to combine 2-3 chapters and take a big PYQ session because organic chemistry PYQs are mixed, right? In some reaction you will see they are not individual questions, you will see very rarely, right? Mostly questions you will see is mixed. I think it is not working only, right? So I don't know what we should do here, right? So I'll just give you the break, right? Okay, I'll start with the break and the time starts now and I'll see you all at 6:05 p.m. So, time starts now and bye bye, right? Hello, 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 hello. Yes, everybody. Everyone in the chat box. Yeah, Manoj, you can watch here for NEET as well. You can watch, right? The syllabus is same, right? The content is same, just the PYQs are different and they are also almost same only for JEE Mains and NEET. So you can watch for NEET as well, right? Okay? Yes, everybody. Do let me know if I am clearly visible and audible to all of you, everybody. And just to remind you, the test series at this point is at 999, which is available to you at a discounted price. Yes, everyone? Okay. So, I was just listening to crackers and all that, you know, Dussehra vibes all over there, right? So, interesting. We are studying on Dussehra as well. What amazing thing, ma'am. Amazing, amazing. So now guys, we'll start with some oxidizing agents, right? That is going to do oxidation here, right? Okay. Yes, students, let's talk about this, everybody. So when you talk about oxidation, let's talk about Bayer's reagent, right? When bacha we talk about Bayer's reagent, right? This is actually alkaline KMnO4. Why? I don't know what is the problem with this one. What is the problem? Yes, I think this one is better. Alkaline KMnO4. Still the cursor is moving here. What is the problem with the cursor? Right? Oxidation Bayer's reagent, that is alkaline KMnO4. When we apply this, when we add alkaline KMnO4 on the alkene, the pi bond will break and here you will have the attachment of OH and OH. That means you will have the formation of vicinal, that means on the adjacent position, diols. Vicinal diols are formed because this color is of pink color. Alkaline KMnO4 is a pink color compound. And here what will happen in this reaction? This is also a test of unsaturation. This is also a test of unsaturation. Do you remember the bromine water test? Bromine water test we discussed, bromine vapors we added. Now in this case, what happens? Pink color is discharged. Pink color discharged. Pink color discharged means that from pink it is getting converted to colorless compounds, right? That is your vicinal diols, right? Okay. JEE is Ravan with 10 shifts of exam, that's right. And we have to, kill this Ravan, that means kill the exam, right? So now hot KMnO4. Acidic, now this is alkaline KMnO4 in which it is converted to OH. What if you have hot KMnO4 or acidic conditions, you have potassium permanganate or dichromate? Alkenes is converted to ketones or acid depending upon the nature of the alkene. So this is, I'll just write here what will happen here. So what if you have, this is double bond, right? This will be converted to 1, 2, 3, this is OH, this is 1, 2, 3, this is OH, right? Then because it is acidic, so what will happen? This particular bond will break, right? And hence you will convert it into ketone. You will have the conversion of it into, this bond will further break because it is acidic in nature and you will have the formation of alkane, okay, ketone, right? If it is further more oxidizing in nature, right, then it will be further converted to, let's say you have H here. Then this H that is attached to the carbonyl carbon will be converted to OH. That means further acids also it can be converted to, right? So that means if you have alkaline, only then you will have vicinal diols. Otherwise the reaction will further take place, right? Okay. Now, here as we are doing it, dilute KMnO4 is Bayer's reagent, alkaline KMnO4 is Bayer's reagent. Acidic KMnO4 is not Bayer's reagent, right? If you have acidic KMnO4, hot acidic KMnO4 or hot acidic K2Cr2O7, that is a stronger oxidizing agent as compared to dilute KMnO4. This will form vicinal diols, break the pi bond and attach OH on both the carbons. Here it will break the double bond, attach double bond O on both the carbons and convert hydrogen to OH if present. Let's talk about this thing what we are discussing, right? So you have hot KMnO4. If you say you have alkaline KMnO4, Bayer's reagent, this pi bond will break, this will be R, this is H, this is H and this is H. This will be converted to OH and OH, that means simple vicinal diols are formed if you have alkaline KMnO4. Now, if you have acidic KMnO4, what will happen here? Let me just, these questions are directly, so you won't be able to understand. I have to tell you what is the process of doing this. See, here break the pi bond, break both the double bond, attach double bond O, this will be R, this will be H. Break the double bond, attach double bond O, here also break the double bond O, attach double bond O. Because it is further being oxidized, so what will happen, right? Because it is hot KMnO4. So again, the hydrogen that is directly attached to the carbonyl carbon will be converted to OH. So here this will be converted to RCOH double bond O. This is converted to C double bond O. This is OH, this is OH. This is nothing but this is actually H2. This means it is nothing but this is H2CO3, which is further dissociated to H2O and CO2, because on one carbon 2 OH are not stable, so it is further dissociated to H2 and CO2. This is your RCOH and this is what we wrote is the final answer here, right? Okay, right? Yes. Awesome. Tell me, is that clear? Is that clear? Tell me what I am telling you. If you have dilute and alkaline KMnO4, directly vicinal diols are formed with the same reactant. If you have acidic KMnO4, then firstly break the double bond, attach double bond O, right? Then hydrogens that is directly attached to the carbonyl carbon is converted to OH here, right? And that's how you will have the formation of acids here, right? Tell me, everybody, is that clear? Is that clear to all of you or not? Is that clear to all of you or not? Students, tell me, this is a very, 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 very important difference of alkaline KMnO4 and acidic KMnO4, right? Mark it very, very important, right? It's very, very important. And direct trick I have given you here. It is weak, it will form vicinal glycols, vicinal diols you can say. Carboxylic acid or ketones will be formed. How? Break the double bond, attach double bond O, then convert hydrogen to OH if present on the carbonyl carbon, right? Okay, yes, yes. Now next is this we have done hot KMnO4, which as I already told you, direct this you won't be able to remember. How do you remember this? Okay, you will not remember that ethene will give carbon dioxide, so you should not remember that much. Directly break the double bond, attach double bond O, right? Attach double bond O, then hydrogen directly connected to the carbon is converted to OH. That means this will be converted to C double bond O, OH, right? This will be converted to C double bond O, you can also write it like this, C double bond O, OH. This is nothing H2CO3, that will be converted to H2O plus CO2, converted to H2O plus CO2. That's why overall the answer was 2 water and 2 carbon dioxide was the answer there. Right? Okay. Yes. Ramcharan, you are at least do it today. You are talking to me as if you are my boss, right? Okay? I promise to you, but I have my personal life as well. From till 11, I was taking the class, right? In the morning, I am taking the classes, right? Dussehra it is today. Everyone is out there celebrating. I am taking the class, right? I'll see that, right? Can you be more polite here, right? You're not my boss to tell me, ma'am, at least do this today. It's not a work that you have assigned to me. I'm not responsible for that. But still, I told you that I'll do that, right? You can be, at least you can be more polite to me, right? This is all you can do, right? You're asking as if, right, you know, I don't know. I mean, bro, understand. We also have our life, personal life is also there, right? Still, because on the festive, today it's off in Vedantu, right? I'm still teaching you. Share sir will also take the class, right? This is the dedication that we show you, right? Acha, tell me. Ma'am, I didn't understand. Which part you didn't understand? Tell me. Which part you didn't understand? Tell me. But just see, if you have here, if you have Alkaline KMnO4, right? Then this will be C single bond, this will break, this will be OH, this will be OH, this will be H, this will be H, this will be H, this will be H, right? Pi bond will break, OH, OH will be attached. If you have acidic, break the double bond, attach double bond O here, attach double bond O here, right? You will have the formation of ketone. Then hydrogen that is directly attached to the carbonyl will be converted to OH. Now this is H2CO3, which is not a stable compound, so that is directly converted to H2O and CO2. This is what you have here. Okay, tell me, is that clear? It's okay, Ramcharan, it's okay, right? Yes. Tell me. Right? Understood? There you can see the sound of crackers. Oxidation is hot KMnO4. Achha, this we have done. Na? How many times we'll have to do this? This we have done. Okay? Okay. Next, guys, we have complete oxidation. That means we are providing air. This, if you remember, we have done this yesterday as well. This is for alkene, right? This is for alkene and this is for alkyne. This is for alkyne. This is, if n number of carbon is there, 3n plus 1 by 2 amount of oxygen you will give. N number of CO2 will be released, n plus 1 amount of H2O will be released. Right, here n amount of H2 will be released, here n minus 1 amount of H2 will be released. Right, see, I'll tell you a simple way of remembering this. Alkane, alkene, alkyne, you know the formulas. Here it is plus 2, so here you will have plus 1. Here you have nothing added, here also you will not add anything. Here you have minus 2, so here you will add minus 1. Simple. Here you have plus something, so here you have added plus 1. Here you have plus nothing, so here you will not add anything. Here you have minus something, so here you will add minus 1. Right? So that's a simple way of remembering this thing. Right? Okay. Now next is Wacker's process. So it's a direct formula, direct reaction that you should remember, that this is an alkene in which you will have, when you give not full, like half amount of O2, that means partial oxidation is happening in the presence of PdCl2 or CuCl2, and this is important process. Okay, then this particular bond will be directly converted to, that means here one hydrogen will be added here and this bond will be directly converted to double bond O. Okay, so what will happen? This pi bond, this will break and this one hydrogen you will add here and this will be directly converted to double bond O, and hence you will have the formation of aldehyde or ketone from here, right? Okay, that is formed here. That is your Wacker's process, right? Next guys, we have ozonolysis. It is quite similar to what we have done just now, right? This involves addition of ozone molecules to the alkene to form ozonide. So what is ozonide? Let's talk about that. So this is ozone. When you add O3 here, one pi bond will break, you will have OO here. Another pi bond, and two bonds will break here, and here you will have oxygen. This kind of situation you will have, right? Basically a hut will be formed, right? Like a hut, no? Like a hut, it will be formed. Here you will have oxygen, here you will have oxygen. Wait a minute. Yes. This thing. Here you will have oxygen, here you will have oxygen, here you will have oxygen. Right? That thing is called as ozonide. Okay? So this ozonide, you should know what is ozonide. Ozonide is from cleavage of ozonide by ZnH2SO4 to smaller molecules. This reaction is highly useful in detecting position of double bonds in alkenes and other unsaturated compound, and it is one of the most repeated questions. You talk about JEE, you talk about mains, it is one of the most repeated question, most repeated and most important, right? So mark this very important, right? Okay. How to remember all of this? You have to practice it again and again to remember all of this, okay? That's how to, right? Okay. So if you talk about guys, let's talk about how it will be done. I'll give you a simple way of understanding this. There are two kind of ozonolysis that take place, okay? So first is reductive ozonolysis, then there is oxidative ozonolysis, right? Reductive ozonolysis, we use zinc. In addition to O3, you use zinc or you use Me twice S, right? For oxidative ozonolysis, we use H2O2, that is oxidative ozonolysis, right? So what you do in reductive ozonolysis, you break the double bond, apply double bond O, right? And in case of oxidative, after the reductive ozonolysis, the compound you have, you will do the after reductive ozonolysis convert hydrogen to OH. I know till now you are like, ma'am, I don't know what you are speaking. Let's talk about an example, right? So if you have reductive ozonolysis O3, let's say you have Zn here, break the double bond, attach double bond O here. This is double bond O, CH3, this is H, okay? This is double bond O, right? This is CH3 and this is H. Break the double bond, attach double bond O, right? Okay, break the double bond, attach double. This is the product of reductive ozonolysis, right? Or they can also give you here, you have O3 Me twice S, right? You will have the same answer. Now let's see the next one that you will do. If they, instead of giving you further, they are giving you that oxidation is happening, that means oxidative ozonolysis. Very rarely they will ask you oxidative, but what if they give you peroxide, that means oxidative ozonolysis they are talking about. Now see the hydrogen that is connected to the carbonyl carbon, that will be converted to OH. So this will be C double bond O, this is CH3, this is OH, okay, and this will be C double bond O, this is CH3 and this is OH, right? That is CH3COH. Only H2CO3 will be converted to H2O and CO2. Other acids will remain as it is. Okay, so this is going to remain as it is. You will have the answer of acids, and if you have reductive, you will have ketones or aldehyde as the answer. Tell me. Okay, yes. Okay, it's okay, Ramcharan, it's okay, Ramcharan, it's okay, right? My duty is to tell you, right, what are the words that you should not speak to a teacher, right? Because there are so many things that are going, right? Continuously we are teaching in batch, we are teaching here, right? So many things are there, right? So in my life, apart from JEE also there are things. In your life it is only one thing, but still I am teaching on the Shera, right? So appreciate that, right? Okay, so tell me, is that clear? Now let's talk about polymerization. In polymerization, what will happen? Polymers are high molecular masses substances constituting of large number of repeating structures, right? The simple molecules which combine to give polymers means n number of that chain will be linked together to give a polymer, like PVC, polythene. Polythene that you have, that is actually not polythene, it is polyethene. The polymer of ethene is polyethene, that we call polythene. PVC, polyvinyl chloride, that we say PVC on our floors, PVC on our walls, we want to decorate. What is that? It's a polymer, okay? Teflon, it's a polymer, right? So the processes by which simple molecules are converted to polymers is called polymerization. So n number of ethene, when it is under at high pressure, high temperature, it will form you polyethene. If you have n number of propyne, right, it will give you polypropene. Now polymers are there in JEE Advanced, right, till now, right? So you can do it for this. In JEE Mains there is no polymer, so you can just remember one or two here, right? Not that important, but yes, you should know what is that process and some important ones. That's it. Addition reaction in case of hydroformylation reaction. Hydroformylation means formyl and hydrogen will be added, right? In that we add CO plus H2, cobalt 150 degree, high pressure, drastic conditions you have here. Now here pi bond will break and CH2, two kind of products will be formed. Either CH2 can be connected here or CH2 can be connected here, right? Both the products are equally major, right? Both the products are good products. There is no major minor here. This is CHO on this position and hydrogen on this position, or the opposite. That is CHO on this position and hydrogen on this position. Why it is called hydroformylation? Because you are adding hydrogen here and formyl group here. Formyl here and hydrogen group here. That's why it is called as hydroformylation, because two things are added, hydrogen and formyl group. Okay, then this also is a very important reaction. Mark it, very important. This also is a very important reaction, that is substitution reaction. Okay, let's talk about this substitution reaction, everybody. Ma'am, if then ketone will be formed. Here you are talking about, na? Then ketone will be formed. If you say that, ma'am, here CH3 is formed. Let's say, okay. If here, let's say you are saying, ma'am, here CH3 is there. Here you have, ma'am, CH3. Ma'am, this is also, let's say this is also CH3, right? Then this will be CH3, right? Then this will be CH3, right? This will be CH3. Further acids conversion will not take place, right? So this is also CH3, this is also CH3. Now with oxidation, it will remain the same, right? It will remain CH3 only, right? Whether it's reductive or oxidative, if there is this kind of situation, it will remain the same. In oxidative, only those hydrogens are converted to which are connected to carbonyl. If there is no hydrogen connected to carbonyl, then it will not take place. Guys, yes? Okay. Yes, everybody, do let me know if that is clear. Now let's talk about this one, substitution reaction. Substitution reaction. In substitution reaction, here you have allylic or benzylic. Now, what is allylic, what is benzylic? Let's talk about that. Okay. What is allylic, what is benzylic? Let's talk about that. When you talk about allylic, right, that means you have a double bond and Next to the double bond, you have a carbon. This is allylic carbon. When you have a double bond, right, this carbon which is having the double bond is the allylic, is the vinylic carbon. Benzylic is when you have a benzene ring, right, when you have a benzene ring, and carbon next to it is your benzylic carbon. Now, if you have attachment of OH here, then this will be called as allylic alcohol. If you have attachment of OH here, this is vinylic alcohol. If you have OH here, this will be called as benzylic alcohol. Now, if you have attachment of halogen here, that will be called as allylic halogen, vinylic halogen, allylic halide, vinylic halide, benzylic halide, right? So what we are saying that on this allylic position, you have a hydrogen here, you also have a hydrogen here, you also have a hydrogen here. So is there any substituent that will specially not this vinylic will not be, vinylic is this one, this I just explained you. But is there any substituent which will specially replace the allylic hydrogen or benzylic hydrogen? Then that substituent is, okay, that substituent is Cl2 at high temperature, SO2Cl2, Br2 at high temperature, or N-bromo succinimide, okay. These are the substituents. For example, you have this kind of situation, right? You add Br2Hμ or you add Br2CCl4. Answers will be entirely different here, right? In case of Br2CCl4, what will happen? Pi bond will break and you will have the addition of Br here. That is anti-addition, if you remember, right? Anti-addition will be there. Now it also depends upon, now this is a trans product. Trans and anti will give you same side. Actually, it will give you this kind of product. If you remember, this is trans. Trans means negative. Trans, and this is anti-addition. Do you remember that? Trans and anti. Trans, anti, this is also negative. Negative, negative will give you same side, bromine will be added. So here this kind of product will be formed. But in case of Br2Hμ, allylic hydrogen will be substituted. So this is the allylic hydrogen. Double bond, the carbon connected to it, and here you will have the hydrogen. So this will be 1, 2, double bond here. This will be CH2Br. Allylic hydrogen will be substituted here, right? Okay, everybody tell me. It depends upon, by just one thing, CCl4Hμ, everything has changed here. Product has changed, and this is what they want you to know. This is what they will ask you, right? This is what they will ask you. Now tell me here, which is this allylic or benzylic? Tell me. Bacha, tell me, is this allylic or benzylic? Tell me, everybody. I want to know, is this allylic or is this benzylic? Yes, everybody in the chat box. Right? Okay. Yes, everyone. Is this allylic? Is this benzylic? Red is not visible. Tell me, allylic, very good, very good. This is allylic, very good. Double bond, then carbon, and this halogen is allylic, right? Very good, this is allylic. For benzylic, this overall should be a benzene ring. So this will be allylic, not benzylic, right? Okay. Now tell me, in this case, you have SOCl2, what should happen? You have SOCl2, what should happen? Yes, everybody? CH3. This is the allylic carbon. On the allylic carbon, you will have substitution reaction, because this will produce Cl, so this will be CH double bond CH2, and that will be the answer here what you will have. Okay, yes, allylic position will be substituted here. Okay, right. Now in this case what will happen? This is also allylic, this is also allylic. So when you have these kind of cases, more substituted allylic is preferred. Okay, so in this case what will happen? More substituted allylic is preferred. So this is the double bond here, this is allylic, so this will be Br and this will be CH3. Okay, because this is the allylic carbon, this is not allylic. Next to double bond, this is allylic, so that will be substituted, and hence the answer will be this one. Tell me, is that clear everybody? Is that clear? Do let me know in the chat box if that is clear to all of you or not. Right? Yes, students. Chemical properties of alkenes. Let's talk about the chemical properties of alkenes, everybody. Achha, I'm saying chemical properties. I'm so sorry, I just zoned out for a second. Achha, isomerism, if you talk about, isomerism means two isomers can be formed here. This is one isomer. From this one isomer, you can have, for example, if I say this is 1 and this is 2 and this is third. First and second are the position isomers. First and third are the, these are the position isomers, these are the chain isomers, because chain is, this and this chain is different, right? Second and third is also the chain isomer, right? This I have done in isomerism as well. Now, how to convert one isomer to other isomer? Directly using the catalyst like AlCl3, Al twice SO4 thrice, right? Aluminium sulfate, aluminium chloride, you can directly convert one isomer to the other isomer. This is not asked to you, so I am just telling you that this is there, right? But it is not asked. Now guys, let's discuss about die-in, because you have some very important reaction in die-ins. Okay, let's discuss that, right? Okay, yes everybody. So what you have, die-in means more than one in you will have. So three cases are possible. One is you can have isolated alkenes, that means double bond, then single bond, then double bond, then maybe after 5 single bonds you will have a double bond. So they are not next to each other, they are not alternates, right? If you have next to each other, you have double bond, that is called cumulative or allenes. It's not alleles, it's allenes, okay? Allenes, right? That will be called as allenes. Now tell me, have we discussed about allenes? Have you discussed it anywhere? Yes. Do you remember we talked about this in case of optical activity, that when you have double bond next to each other, they will have a perpendicular plane, right? This we talked about, that when you will, how you will find out this is optically active, it's optically inactive. So that portion is a portion of alkene that I have already discussed there, right? I have already discussed this there in the isomerism part, in stereoisomerism, in optical activity we have discussed about this thing, right? So that is your allene, that is cumulative alkenes, or that is called allenes. Then conjugated alkene means double bond, single bond, double bond, single bond, double bond, single bond, alternate double single bond. Isolated means there is no pattern here, they are not next to each other, they are not alternate. It's not like that, right? So they are isolated, right? Now let's understand this part, that is addition of conjugated diene. Achha, tell me, have we done this? Yes. Do you remember we have done this? Do you remember that? Yes, we have done this. How we have done this? Tell me. We have done this. In yesterday's lecture only we did this. This is CH, this is CH. Right? Do you remember 1,4 addition product? This is CH2, this is CH2, right? And here, for example, you are adding anything. Let's say you are adding halogen here, right? So what will happen here? Hydrogen I have already taught you. Let's talk about halogen. So this bond can, wait a minute. This bond will shift here, this bond will shift here, this bond will shift here, right? And hence you will have the formation of, this is CH, double bond, this is CH, this is CH2, this is X, and this is CH2, and this is X. So can you see this is 1,4 addition? Can you see guys, this is 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So that means you have added halogen on the 1,4 position. So this is 1,4 addition product. 1,4 addition product. Okay. This is called as 1,4 addition product. Okay. Now two things can happen. Either you can have 1,4 addition product, which will be the major product, or you can also add it directly here on this position 1, 2 addition. That means, or you can just directly add CH2, this is X and this is CH, this is X and this is CH double bond CH2. That is 1, 2 addition. That is 1, 2 addition product. Okay, so both the products are possible, right? 1, 2 addition is simple to understand why it is happening, but 1, 4 addition, I told you that how it is happening, right? Then the next is Diels-Alder reaction, very, very important. Diels-Alder reaction, very, very important reaction, right? For dienes, Diels-Alder reaction, let's talk about that. In Diels-Alder reaction, what we are going to do, right? You will have a conjugated diene, right? And you have a alkene here. In Diels-Alder reaction, two alkenes you have. This double bond will shift here, this double bond will shift here, this double bond will shift here. And can you see this kind of structure will be formed? A new bond is formed here, a new bond is formed here, a new bond is formed here. This bond we have already break with this bond is not there, right? So that's how you have the formation of, this is actually Diels-Alder reaction. I'll show you one of the questions of Diels-Alder reaction like this, okay? This is a very important question which is based on Diels-Alder reaction, okay? Everybody see this, right? What I'll do, I'll just not add the plus sign here. See what will happen, this bond will shift here, this bond will shift here and this bond will shift here. And hence what you will have, this is 1, 2, 3, this is double bond that you have formed here, the new double bond that you have formed, right? Everything else is same, this is CH3, this is the new bond that you have formed, this is the new bond that you have formed, everything else is same, right? And this is double bond O, this is double bond O and O. This is from Diels-Alder reaction, and this is a very important question. This is asked in your PYQs of JEE Mains, right? This is already asked question, right? It's a very important reaction, so mark it important, right? Yes, everybody tell me. Ma'am, in MBS does the product based on, no. In MBS N-bromosuccinimide directly substitution reaction, it will show either benzylic or allylic hydrogen will be substituted by the bromine, okay? Yes. Chalo. Right? Okay. Now, acha, this we have done, right? Diels-Alder reaction. That's it. That was about alkenes. Now let's discuss about alkynes. Discuss some points about alkynes. Yes, Vicha. Tell me, alkenes we have done and it was a major task. Alkanes and alkene is the major task in your hydrocarbons, right? Very major task. Then we talk about this alkyne. Alkyne is like, it is there, a big amount of questions you will see there, right? Okay. Ma'am, what's happening? I don't know what is happening. Why are you asking me what's happening? Are you guys tired? Tell me. Let's do something. Alkynes, I'm not going to complete today. Alkynes, don't worry. Right? It's not possible. And also for tomorrow also we need something. So I'll do just preparation of alkynes. Okay? Maybe next 30 minutes, 20 minutes. Okay? More 20 minutes. Okay? 20 minutes more you can have patience. Right? So that tomorrow the lecture is just because I really want to complete the lecture tomorrow so that you can have Saturday. Saturday I'm not taking the class, right? So Saturday and Sunday you will have for your revision. Do homework, right? Like I'll give you the homework also and revise everything. More revision because you know more you revise the notes again and again, write it yourself. It will help you. It will really help you. Right? Okay? It will really help you. Saturday and Sunday, utilize it, solve the previous year questions from hydrocarbons, try to do it yourself. Right? Firstly, pick out NCERT of hydrocarbons and solve all the conversion reactions from there. That is your homework for Saturday and Sunday. If you are not doing that, you are not lying to me, you are lying to yourself. Right? I will not get admission into IIT. You will get admission into IIT if you do this, right? And if you don't do this, forget about IIT. Even NIT will be not possible. Even some good private college will be difficult for you if you don't do this much, right? Then you will have to pay like in lakhs and also get admission into a college where no placement will be there, right? Competition is very high, guys. Competition is very high, right? Understand that it's not, the task is not, why the task is to get into a good college, because in good college you will have good opportunities. The first opportunity you will get will be good, right? The placements will be good, right? Obviously if you have studied in college as well, and the exposure will be good in a good college, right? You will meet professors who are already well trained, right? So that's why it is important. Right? It's a very crucial time and understand that. Pay attention to it. Don't get demotivated so easily. You have festive season at this point, and if you ruin your festive season, guys, you are going to get disappointed by yourself. Right? Don't ruin it. Diwali can come next year as well. Diwali, Dussehra, everything will come next year, no? But one thing, I'm not saying whole day, Diwali, Dussehra, don't celebrate, study whole day. Celebrate it for 1 hour, sit with your family or go out with your friends 1 or 2 hours, you can give. But if you're spoiling your whole day in the festive season when your JEE exam is so near, right, then you are definitely making a very big mistake. This is an opportunity for you where everyone else will be ruining their time because of festivals. And you have to grab that opportunity. This is the opportunity to complete your backlogs. This is the opportunity to be pro in things. That's why we have launched the test series at this point. Because we know that right now you will have time for practice. Right? You will have holidays. You will have school off will be there. Right? So go and do that. This will really help you. Okay? Right? Ma'am, I have 1 hour potential. Please start. Okay. Now this yeah, what is the name of the channel? Vedantu J English. Do you really think so? I have shame in speaking Hindi. Like really? This is an English channel. This is created to have no language barrier, right? The reason for this channel is that, right? We don't want to limit it to only those students who know Hindi or this or that language. Even if in your regional content you are not getting a good content, then watch it in English. That's why this channel is for. My mother tongue is not English. I am speaking it. So you can also understand it, no? Right? I am also not pro in English. I am just speaking handicapped English. Right? So still I am speaking, no? I am not, you know, like making some accent here, some accented English I am not speaking, normal Indian English I am speaking, right? So you can easily understand that. Achha, before that, I just want to let you know that test series is at 999 available to you, and right now you also have time to practice Bacha, you will have topic wise tests, part syllabus, full syllabus tests, everything you will have here, and this is a very less price. Triple line, trust me, this is a very, very, very less price. Grab this, right? You're going to regret it later otherwise. You still have time for practice. You still have time. So do make use of it. Okay? Make use of it. Right? Yes. Now let's talk about what is alkyne, guys. Alkyne is triple bond, right? You have triple bond here, that is alkyne. So in alkyne you have 1 pi, 2 pi, 1 sigma. 2 sigma bonds, triple bonds, 2 pi bonds and 1 sigma bond you have here. Sp, why it is Sp? Because you have 2 sigma, 1 sigma and this is sigma. Overall carbon has 2 sigma bonds, that means it is Sp hybridization. That means it will be linear. The formula is CnH2n minus 2. It is cylindrical pi electron cloud. That means this electron cloud here is like a cylinder. Why? Because here it is in 2 directions, actually the overlapping, sideways overlapping is happening. That's why it is a cylindrical pi cloud that is there, right? Okay. Then isomerism in alkynes. If you talk about the isomerism in alkyne, it shows chain isomerism, position isomerism, functional isomerism as well, right? Let's talk about how. If you talk about the position isomer, it can show you C triple bond C 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. It can also show you 1, 2, 3, 4, 5. Double bond on second, double bond on triple 1, 2, 3. That will be same only. 2 position isomers it can show you, if you see here. 2 position isomers it can show you, right? So position isomer definitely it is showing. It can also show you chain isomer like 1, 2, 3, 4 and there is one chain over here and this is the triple bond, right? This is CH3. Now chain is 4 carbon, okay? This also it can show you. 1, 2, 3, 4. The 4, 5 bonds are not possible here. So chain isomer it can show, but this one will not show. 1, 2, 3. If you talk about 4 carbons here, right? It can show you, wait a minute, let me just show you how it will show you chain isomer. Wait a minute, let me just draw a chain isomer here. This can have hydrogen here, this can have C, this can have CH3 and this can have CH3. Now it can show you chain isomer. Can you see? 1, you can have 1, 2, 3, 4. This is the main chain, right? And on third position you have the methyl group. So here you have 5 membered, right? This is also 5 membered, right? So can you see the chain is different? So chain isomer is also possible here. Position isomer is also possible here, right? So 2 things we have seen, that chain and position isomer, how it is possible. What about functional group isomer? What about functional group isomerism? Functional group means it can also show you 1, 2, 3, 4, 5. A double bond here, a double bond here. This will be CH3, CH, CH, CH and CH2. 3, 4, 5, 6, 7, 8. Is it 8? 3, 4, 5, 6, 7, 8. Yes. Can you see this is diene? Diene. So the bond has changed. So if you say this is the first structure, this is second structure, this is third and this is fourth. Then 1 and 2 are position isomer. 1 and 3 are chain isomer. 1 and 4 are functional group isomer where the bond has entirely changed. Okay, yes, tell me, is that clear? Tell me. Tell me everybody. Okay, yes. Now let's talk about the next part, that is geometrical isomerism. Now geometrical isomerism is not shown by the alkynes. Why? Because for geometrical isomerism, the condition is that you should have, this is 1, this is 2, this is 1, this is 2. 1 should not be equals to 2 for GI. But in case of triple bond, you have only 2 things here. On one carbon, you don't have 2 different, there is only one substituent. So there is no point of saying that 2 different substituent on one carbon. There is only one substituent here. So that is the reason no GI is shown. Okay, because the condition is on one carbon you should have different substituent. Forget about different substituent. It has only one substituent. So that's why it is not showing any kind of geometrical isomerism. Right? Now guys, let's talk about preparation of alkynes. Guys, everybody do let me know. Do let me know. Shall we do it? Shall we do it? Tell me. Shall we do it today? If you are exhausted, I can also do it tomorrow. Let me see how many preparation steps we have. Okay. 7-8 preparation steps you have. Tell me, if you want to do it tomorrow, I can also do it tomorrow. There is no issue in that. Tell me. Whatever you say, I'll do that. Whatever you feel, I'll do that. Tell me. Yes, everybody? Yes, I am not Chandu. Okay. Tell me, everybody. Do you want to do it in the next class or today itself? Or today itself? Your wish, ma'am. Maybe tomorrow, ma'am. Okay, Ramcharan is saying, ma'am, maybe tomorrow. Abhishek is saying, your wish, ma'am. Okay. Okay. So let's do it today only. Okay, let's do it today only. Only 7 reactions you have here. Let's do it today only. We'll be able to do it. Okay? Right? Let's do it, everybody. Yes, everybody. Let's do it. Right? At least let's do 3 preparations here. Let's do 3 preparations today. 3 or 4 preparations. Half of 7 preparations we have. 3 or 4 preparations we'll do today. Rest of it we'll do in the next class. Okay? From calcium carbide, okay, when you talk about calcium carbide, so you have CaCO3 here, right? That is after heating is converted to quicklime and oxygen. This quicklime, when it is reacted with carbon, it is going to give you calcium carbide. Now guys, this calcium carbide, when it is reacted with water, it is going to give you ethene. Ethine. This is a very, 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 very important reaction. Calcium carbide, it's a very repeated reaction, very important reaction. Calcium carbide with water will give you ethine, and magnesium carbide with water will give you propyne. Right? Calcium carbide with water is going to give you ethine, 2 carbon, triple bond. Magnesium carbide with water is going to give you propyne, that means 3 carbon. Okay? 3 carbon. Right? Okay? Yes, everybody. Calcium carbide, ethine. Magnesium carbide, propyne, both are very important reactions. Very important. Directly they start from here, then further reactions. After this, now the chemical properties of alkyne that we'll study, that will proceed from here. Right? Okay? Next is the difference in the behavior of this and this is due to the difference in their structures. Al4, aluminium carbide, beryllium carbide do not form any alkyne on hydrolysis. Instead, they form methane on the hydrolysis. Okay? Instead, they form methane. Aluminium carbide and beryllium carbide, they will not give any alkyne on the hydrolysis. You don't have to remember other carbide. Just remember that calcium will give you Ethyne and magnesium will give you propyne. Aluminium and beryllium will not give you any alkyne. That's it. This is all you need to know, right? Then there is from vicinal dihalides. This is the second preparation. Now guys, what is vicinal dihalides? On adjacent carbons you have halides, right? That means you have adjacent carbon, you have two halides. Now when you react it with an alcohol, right, you will have the elimination of bromine and hydrogen from here. Let's say bromine is eliminated, here hydrogen is eliminated, double bond is shifted here. Alkene you will have. Then again, you are using a base here, this is also base, this is also base. Again, hydrogen will be eliminated, bromine will be eliminated, double bond will shift here, you will have the formation of alkyne. Now guys, remember one very important thing here, that this is also acting as a base. This is also a base that you are using. But ma'am, why can't we use KOH and KOH here also? Why here we have KOH alcoholic? KOH alcoholic is a very good dehalogenation reagent. It eliminates hydrogen and halogen from beta positions. That we know. We have done it in preparation of alkenes as well, right? But then why here we have to use NaNH2? Because to take out halogen and hydrogen, to do dehalogenation from the alkane, it is easy, that's why we use alcoholic KOH. But now we need even a stronger base, and this NaNH2 is a stronger base as compared to alcoholic KOH. So that's why in the second case you will use NaNH2. Okay, so basic strength of alcoholic KOH is weak as compared to NaNH2. That's why it is used here, right? That is why in the second step NaNH2 is used, because a stronger base is required. I'll tell you why more detail. So in alcoholic KOH, after elimination you have this thing, right? Now if you see this thing, isn't it resonance stabilized? Can you see? Lone pair, single bond, double bond. Isn't it resonance stabilized? Double bond, single bond, lone pair. This resonance stabilization will make it so stable that it will be very difficult to take out halogen and hydrogen from here. So that is why we have to use a stronger base here. That's why we are using a stronger base to eliminate halogen and hydrogen from here to convert it into alkyne. Tell me guys, is that clear? Is that clear to everybody or not? Is that clear to everybody or not? Guys, do let me know in the chat box if that is clear to all of you or not, right? The likes are still very less likes, huh? So much efforts I am putting, but no likes you can give. I'll have to ask for that, right? Chalo. Now the third is from geminal dihalides. What is geminal dihalides? Geminal means on the same carbon you have halides. Now in this case, first is you will use alcoholic KOH. So what will happen? Halogen will be eliminated. Here hydrogen will be eliminated. You will have formation of this double bond. Again, this is a stable compound because of the resonance, double bond, single bond, lone pair. Because of its stable resonance here, what we will say, again you will have to use a stronger base to eliminate halogen and hydrogen from here so that a triple bond you can form here. Same reaction it is for geminal and vicinal dihalides. Do let me know if that is clear to all of you or not. Yes guys. Is that clear? Tell me. Because I am not having Sigma batch, but I am teaching in Sigma batch. So I can tell you for sure it's worth it. Right? Yes. Vicha, tell me, is that clear? What is, how to do geminal, vicinal, 3 preparations we have done. Do you want to do more? From tetrahaloalkane, 4 alkane, that means adjacent carbon, 4 tetrahalo, that means 4 halogen you have. You need to have dehalogenation. Do you remember how we did dehalogenation? Guys, see, For dehydration, we use concentrated H2SO4, right? Or P2O5 or H3PO4. These are dehydrating agents. For dehydrohalogenation, that means to eliminate HX, you use alcoholic KOH. If further from alkene you have to take out halogen and hydrogen, you use NaNH2, which is a stronger base, right? Then for dehalogenation, if you have to take out just halogen, you will use zinc dust here, right? So by using zinc dust, you will directly have the formation of alkyne here, right? Tell me, is that clear? Right? Tell me. Dehydrohalogenation, you will use alcoholic KOH, then NaNH2. Dehalogenation, you will use zinc dust. Any confusion? Any confusion, everybody? Any confusion here? Any confusion, guys? Right? Acha, Kolbe also better. Chalo, let's finish the preparation. Easy it is, very simple preparation. Repetition it is. Repetition of today. Kolbe's electrolysis, you will say, ma'am, scammer you are. What to do? I am doing this for you only. Right? Tell me. Haven't we done this? RCOO Na will give you RR. Haven't we done that? RCOO Na, and if here also it is connected, let's say here it is C is connected, this is also CONA, it will give you C double bond C, right? So if you already have a double bond, let's say C double bond C, COONA, we know that this reaction takes place via free radical mechanism. So this is free radical, this is free radical, right? That will be joined and you will have the formation of alkynes. But do you remember in Kolbe's electrolysis, it's a free radical mechanism. Same thing I am doing again and again. Already done in alkane and alkenes, right? Alkane we did this, we made, you just have to make a bond between carbon and carbon, that's it. Here what we did, we have a carbon COONA, if you want to make alkane, right? You will add carbon and carbon, right? Two of this will form free radical, C free radical, and CC will be formed. Here, this homolytic cleavage will take place, Here you will have the formation of C free radical, it will join and make a bond here, so that is C double bond will be formed, right? And in this case, homolytic cleavage will take place, you will have the formation of CH, this is free radical, and it will give you, this is already a double bond here, it will give you triple bond here. Tell me, is that clear? Okay. Achha. From Grignard reagent, this will chalo. Beta, 2 reactions are left. Tell me, do you want to do it today or in the next class? Dekho, 4 slides are left. Just 4 slides. Let's do it today. At least we'll be happy that we have completed till preparation. We are only left with chemical and physical properties of alkyne and aromatic hydrocarbons. More questions we can do in the next class. Okay? Let's do it today. Very good, everybody. From Grignard reagent, it's a step up. That means more carbon, and it's also a very important reaction. It's a very repeated reaction. Okay? A lower alkyne can be converted to higher alkyne here. Let's see how. Right? You have an alkyne here. To Grignard reagent, you need to give it any proton source. Right? So here what will happen, this is a Grignard reagent, this is a proton source. This proton source will shift here. Do you remember this we did in yesterday's class? Grignard reagent, if it has a proton source, it will form what we did it in the preparation of alkenes. It will form alkane here. CH3 will be converted to CH4. Right? And this MgBr will be connected with this particular hydrogen, and this is what you will have, isn't it? Right? Now, whenever you have this kind of situation, All this is happening because this hydrogen is highly acidic in nature. And this will talk in the next class that why this is so acidic. This hydrogen is like, I want to go. That's why it's a very good proton source. When Grignard reagent finds a proton source, it gets converted to alkane and corresponding alkyne is formed here. Now you have Ri, this is positive, this is negative. So what will happen? This positive R will replace this MgBr and hence you will have step up reaction. Here this was CH triple bond CH. This is CH triple bond Cr. This alkyl chain can be 3 carbon, 4 carbon, 5 carbon. That means you have introduced more carbon into the alkyl chain, and that's what makes this reaction very, very important. This is what makes this reaction very important. Okay, everybody, right? Tell me. Tell me. Yes, we'll talk about, Manoj will talk about this, you are right. In detail, we'll talk about this in the next class. Now, ma'am, can this reaction happen with any other compound also? Yes, any other reagent you give. If you have NaNH2, this is a base wants to abstract proton. If you have a base, this is one of the base, okay? If you have a base wants to abstract proton. Alkyne is quite acidic in nature. This proton will be taken out by this. And here you have the addition of Na positive. This will be formed, and with this again, Ri reacted with Ri. This alkyl will replace the sodium here and hence a higher alkyne is formed. Step up reaction. Okay? Step up reaction. Tell me, is that clear, guys? Any problem in the step up reaction? How higher alkynes are formed? Right, from Grignard reagent we have seen, because Grignard reagent also wants to abstract proton. This also wants to abstract the proton. Once you have any like too much polar bond here, then reacted with alkyl halide, this will be replaced by alkyl part. Similarly, here we reacted it with alkyl halide, this part is replaced by alkyl part, right? Okay. The last reaction of today, right, that is from haloform. What is haloform? CHX3. What is haloform? CHX3, that is haloform. Now let's say this X is chlorine, that is called as chloroform. Do you remember this? In every other serial it is happening. There is chloroform, right? And kidnapper will kidnap you, right? So chloroform, will study more about chloroform in haloalkanes, halorines. Till now, just see how ethyne is or alkyne is prepared for this one. Chloroform, you reacted with Ag, right, directly with the same number of carbon, right, it will get double and you will have the formation of ethyne here, right. So from chloroform or iodoform, you will have bromoform, whatever you have, directly you will have the formation of ethyne in this case from chloroform. Okay? Yes, everybody, do tell me if that is clear to all of you. Right, a lot we have done today. Right, a lot we have done today, and kudos to you for sitting here for such a long time. Hats off to you. Right, I'm so happy that you're so dedicated towards your studies. Right, now guys, let me just remind you again that, wait a minute, questions we'll do in the next class, and isomer of this, the compound is but. So this you can do, isomer A and B, this is a question related to alkene, right, this you can do. Today I wanted to do some PYQs also, but I think today, brain is not braining, so it's better to do it in the next class, right. This is your homework, guys. This is JEE 2022 question. Try to do this today. In the next class, I'll solve it, but only if you do this today, right? Thank you so much, Ramcharan. Thank you so much, Rama, Raju, Manoj and Abhishek, Chandu. Okay, great. Yes. So, this is your homework. Take a screenshot, and before going, guys, do remember that we have our test series launch, which is just at 999 rupees. Currently, the price is 999. The price may shoot up anytime soon. So that's why remember 999 only for this much time, because of the festive season it is there, right? And in this we will have around I think 90 something topic wise test, 40 or something are part syllabus, and full syllabus tests are also there, right? So right now you can start with topic wise test, then you can start with full syllabus, part syllabus test once you complete your syllabus, right? Okay, yes, sure. Only one question, yes, only one question for your homework, right? Okay, questions we will do in the next class, because theory part, very less amount of theory part is left. Okay, so I'll bring more questions in the next class. Okay, yes. But a sigma batch, ma'am, price when it will reduce? If you wait for the price to get reduced for sigma batch, right, you will end up wasting a lot of time. So purchase it now on only, right? So link is in the description for sigma batch. Guys, most of the syllabus is already done, right? So I would just advise you don't waste more time here, right? So you have the option to watch replays there. Everything is in detail. But if you waste more time, then time just flying. Okay, you have to catch it, right? Okay. Manoj, that is not in my hands. Trust me, that's not in my hands. Why would I do that, right? So that's not in my hands. You just have to see that syllabus is same, right? The content is same. You can watch the lectures here. I'm also same, right? So you can watch the lectures here, right? Okay, yes. Okay guys, so bye bye, take care. Now I'll see you all in the next class. Bye bye, bye bye bye. And happy Dussehra, and see you tomorrow at 6 p.m. because 2 hours only we need to complete the lecture. So 2 hours are enough for that. So 6 p.m. I'll join the class and we'll finish aromatic hydrocarbons, we'll finish reactions of aromatic hydrocarbons and alkynes, and we'll do some really important PYQs of hydrocarbons, right? Okay, so bye bye guys, bye bye.